In this tutorial, we are going to look at how to evaluate limits of functions. Suppose we have an equals to root of n squared plus 6 minus n, and we are to evaluate limits of an as n approaches infinity. In this way, the first thing to do is to find the conjugate of an. So in this way, the conjugate of root of n squared plus 6 minus n is square root of n squared plus 6 plus n. So the conjugate of an is n squared plus 6 plus n. So the next thing to do here is to multiply to rationalize by multiplying the numerator and the denominator part by the conjugate of an. So in this way, an can be written as root of n squared plus 6 minus n over 1. So here we multiply the numerator by this conjugate, which is n squared plus 6 plus n. We multiply here too by root of n squared plus 6 plus n. Now the next thing is to multiply the numerator and the numerators separately and the denominators also separately. So you have n squared plus 6 minus n times root of n squared plus 6 plus n all on root of n squared plus 6 plus n. Now the next thing to do is that square root of n squared plus 6 times square root of n squared plus 6 will give you n squared plus 6. Then n squared plus square root of n squared plus 6 times n will also give you positive n root of n squared plus 6. Then we also take n squared times this, so we have n, so we take negative n times the whole of this side, have n root n squared plus 6. Then we take negative n times positive n, so we have negative n squared. Now clearly we could see that this one will cancel this, then this one too will cancel this, so you will be left with 6 on root of n squared plus 6 plus n. Now the next thing is to divide through by the highest exponent, the highest power of n. So in this way, the highest power of n is this one, which is n. So we will divide through by the highest power of n, which is this way. So you have 6 on n. But here we will divide n squared by n squared because of the square root, so that when we cancel out, we get back to n. So you have square root of n squared over n squared plus 6 on n squared plus n on n. Great. So in this way, we are going to have 6 on n all on this one will cancel this, so we'll be left with 1. So roots of 1 plus 6n squared plus 1. So the next thing to do again here is that we now substitute n as it approaches infinity. So as n approaches infinity, then we substitute the value of n here. So we are going to have 6 on infinity all on square root of 1 plus 6 on infinity squared plus 1. We are going to have 6 on infinity squared plus 1. So here then the next thing to do is to evaluate. So 6 on infinity is 0. So we are going to have 0 on root of 1 plus 0 again, then plus 1. So when we evaluate the whole thing, we can now tend to 0. So evaluating limits as n approaches infinity, now the final answer becomes 0. Thank you, and don't forget to subscribe to our channel.